Okay, the issue for today is the Ceramill software upgrade 4.4, it's called. Speed webinar from me. And we will start about the software itself. It changed. The last time we offered the 4.3, and within the 4.3, we installed a additional software on your PC, and this software is called AG Software Manager. You can see on the right side at the bottom. And this software helps you to be sure which software is installed on your PC and which software is now available if something changed with the updates. Why are we doing this? The package size was now too big to send in one piece. So if you have a look to the apps and features, you can see we divided all the modules here. That means we have smaller packages, and therefore for us it's also easier to update only one of these packages here. So this is what we installed in the background. How does it look? I have a small video here. So if I open the AG Live, it's hidden here. It's not AG Live, the AG Software Manager. I'm informed about the version I'm currently using, and if a new version is available, I click on if it's available. I can make the installation and the download directly with the Software Manager. And here I install, and then I'm up to date. So easy information. If you start your PC in the morning and the AG Software Manager pops up, then click on it and be sure that you need the newest update. It doesn't matter if it's a library or the Ceramill software or something else. First, we're going to have a view for the Ceramill cockpit. Ceramill cockpit we also call database, and in database we have a lot of changes. We cleaned and renamed some options and parameter areas. One of these renaming and cleaning is the so-called substructure now. Substructure before was implant supported, and implant supported was not so precise. So we call it now substructure because all the following buttons are substructure types. One new is here, I'll come later to this. And under substructure, it's on custom abutment. Before that, it was abutment in crown. More clearly now is on a custom abutment. That means an abutment out of a library. Meanwhile, we have different more options here. Screw retained stays like it is. On prefabricated abutment, I will come to. This is more or less on stock abutment. What does it mean? It's an abutment prefabricated. The dentist screws it directly in the implant, and this is then more or less the die where you make the construction on it. These are not too much cases where dentists use this kind of abutment, but if you use it, then you can select it in the software as well. Another fine option is under additional. This is the scan body scan. It needs an additional scan body scan, but scan body scan can be divided in two parts. You have a really scan body, that means the dentist makes an impression about the scan body or an intraoral scan and uses the scan body from the special library, or you don't use a scan body. And here for this case, you directly scan the TI base, and later on in the software, you make the position of the screw channel manually. Later on, I will show you how it works. And this is available on custom abutment and with screw retained. So two options now to use the scan body. Bar supported means a construction on a bar. Later on, some more details. So this is more or less which happens in the option and parameters section. So not too much, but in detail, you will have a lot of fun, and it's really cool. So overdenture is one of the new indication, offset overdenture. Offset means a layer on a construction in a certain thickness. This construction can be milled out in our milling machines, 2, 3, and Matic, scanned by our scanners here, and manufactured with our material, sintern, cobalt, chrome, titan. You can read by yourself. I show you how it works. The other option is bar supported. Bar supported means a construction over this overdenture construction. That means some teeth maybe, or try in, or something else. Here is the indication, and here are some materials for that. It will be clear 2 slides ahead. If you click material, normally our milling machines are appearing here. And one of these, this is not a milling machine, one of these buttons now will be called DRS Design Service. And Design Service is a workflow. The workflow is looking like that. A dentist makes a scan, but don't want to mill it by himself. Maybe also not the construction. So he sent the case to the lab, and the lab imports this case with AG Live and clicks DRS Design Service. Then the lab designs a crown or a little bridge, send it back to the dentist, and the dentist has a milling machine, and this is the DRS motion, and he can directly mill it and make it like a chairside construction. So the design by lab workflow is combined with the service of the lab to design a crown, only to design, and send the file back to mill it in the practice. In the past, it was confusing for you to define the scan strategy or the workflow precise. The workflow, therefore, is renamed. It's now called not triple tray and digital impression. We call it now intraoral scan and triple tray impression. So everyone knows if an intraoral scan was imported to the Ceramill Mind, I click on intraoral scan, and then I have this certain workflow following in the Ceramill Mind. So it's nothing happens between the workflow, only the naming makes it more clearly what happened before. So some more features in Ceramill Mind, and I will start here with the map 200 and 600. And here we have a lot of new features with the 4.4 release included, and some are really highlighted. So the free mode enables you to choose between or in between the sequences of the scanning. So it's more or less up to you which scan should be the next, which kind of scan should be the next, upper, lower, vestibular, or I prefer maybe the aesthetic template first, or stuff like this. Then at the end, you can have special designs here. This is a full denture. You can combine things here. So additional scans enables at the end the possibility to combine and align mesh. So if I make an additional scan, and in this case, I made a scan from an old denture. One scan could be the teeth, and one scan could be the base, and I can combine this scan directly in the software with align mesh and the button combine. In the workflow, 2 stone models in occlusion, it's possible to lift up the vestibular scan in the ZX. I think not a lot of our customers are using this. Mainly the articulator scan with Artex CR is used there. If you are not satisfied with the scan result and you want to to have rescans manually maybe, then you can click with the button Extensive Scan to have a better scan quality. That means less holes in your surface. Also, the add of the pre-op scan is able to use directly in the software itself. And what we also changed is the scanning strategy from our vestibular scan with the ARTEX CR. So the strategy is different. We are turning the other way around, and therefore we are nearly 100% precise to be sure that the matching is working properly here. So let's jump in some slides directly in the map. If we start the map, and only in this step it's possible to start with the free mode, and I click on starting free mode, and then a new window appears on the left side in the corner, and here I directly can see which scans has to be done. So upper, lower, and vestibular. On top there's the plus, and with the plus I can directly define if I want to have now an additional scan or not. Before that, it was only possible under this ring on the right side and at the end of all the scans. Meanwhile, the additional scan is possible after the first scan was matched. And an additional scan can be a stump, for example. It could be a second jaw, and I want to combine the jaw. And in our case, it's a full denture, what we would like to more or less to duplicate. So I click on the workflow plus additional scan. Then a new button appears at the toolbar. It's called the Combine Mesh. If I click Combine Mesh, and the next window appears here, and under Combine Mesh, I can select the meshes who has to be combined. So upper jaw and lower jaw. At the end, you have a separated screen, and with one point alignment, you combine this mesh. And this is a waterproof mesh, so you can also directly mill it out if you want. Where does it make sense? Here in this case, for example, for duplicating full denture, or if you have additional dies and you want to combine this with your jaw. The scan would look like this if you have a denture. So we scan the denture from the top, cut parts away which are not necessary, then we scan the denture from the bottom side. Here a denture with a reline impression. We click on Combine Mesh, and then we go to the screen here. I think every one of you knows this, and we have a combination of both meshes here. A really cool feature and a wonderful option which we have. The workflow is not ready yet for duplicate and denture, but this is the first step here in between. Let's go on to full denture impression scan. If you choose full denture in the indication and then set a pre-op model and then go to the scan strategy full impression, then you will guide it through this workflow which I just showed you here. Another nice feature is the extensive scan. So if you want to reduce manual rescanning of your model or of other things, then you click extensive scan. Then the scanner will rotate a little bit more, angulate a little bit more, do much more pictures in between, and then you can avoid a rescanning manually mode. Also, a really nice feature is the new strategy for ARTEX CR. Sometimes it was not working that the models are matched properly in the vestibular scan. Meanwhile, we are very close to 100%. Matching is working. The only thing where we sometimes have difficulties where when we are using a full dentures, then this area is more or less missing. And then I have only the edge of my model to make a referenciation. There it could be necessary to make the 1-point alignment, but all in all, it would work fine in the future if you have, like here, teeth all over the arch. You're also much faster here. Everyone of you, I think, likes to work dark. Dark and black is very actual, this mode, and we implemented now the dark mode as well. So in the software, it's possible to choose in the background another color. We have our color. This is more a grayish one, but also dark is not so bad. It reduces extremely the stress of your eyes during the construction of cases if you are sitting the whole day before your screen. So dark mode will be available. It looks like this in the Ceramill Mind. So also the contours are very sharp if you select the dark mode. And where can you select the dark mode? You go to the settings and you have to select the dark mode in every software module separately. So in Ceramill Map, you can order the dark mode, in Ceramill Mind, and in the Match 2 also. So order it here, and then it will appear in the dark mode everywhere. A nice feature is the overdenture. We made a lot of tests and wanted to make an easy workflows. Before that, it was a workaround. Customers are using very often the copying function, but we now implemented a workflow, and the workflow means not only the function like copying over the structure of a bar, also the intelligent block out is important to deliver a good design and milling result at the end. So one thing is the offset denture, and the other thing, I come to this later, this is the bar supported construction. So offset over denture leads you through a workflow to a minimal layering over the bar, like not only a stabilizer, more or less like the base of the denture or prosthesis you want to construct over it. The materials we set up for this is for the overdenture sintron, cobalt chrome, titanium, PEEK, and wax and acrylic. And for the bar supported, that means for the construction part over the overdenture, we have sintron. If you want to veneer it, for example, we have ATEM for try-in, PEEK, wax, and some kind of zirconia. Very common and modern art to make this kind of full arches here is to set up a bars on implant, make a offset overdenture here, mill this part here out of zirconia and glue these two parts together. So at the end you have a fitting, more or less a passive fitting from your zirconia on the bar, and this avoids the stress from the bar. At the moment it's not possible with screw channels, but it will come, it will follow. And for those who would like to make an overstructure here, overdenture, like our German crown, the telescopic crown, you can make a raw data import in the Matic. This is possible, and try out. At the moment it's not approved. It will come, but at the moment it's more or less an overdenture without friction. Maybe you design with these elements here in Germany. This is called Prezi Vertex, and the Prezi Vertex is like a snap on some parts of the bar, which hold the overdenture and at least then the bar supported construction. Where do you find this indication? The offset overdenture at the beginning in the database. This is one more feature in the removable part. And the bar supported is on the right side between options and parameters. And bar supported, if you click this, you will be guided with a special workflow to design this kind of constructions. One more look for the milling at the end. So milling strategy for overdenture is prepared for zirconia, sintron, PEEK, titanium, and cobalt chrome. For the normal materials, let me say like this, zirconia, sintron, and PEEK very fast. Cobalt chrome, of course, a little bit more, because maybe sometimes you have only a structure here with a thickness 0.6 millimeter, and the rest has to be milled away. We also made some tests with the bar supported and zirconia, sintron, PEEK, and composite. This is the estimated time we can give you here. With the implant features, yeah.
I think we have one more important information about the material.
Okay. Yes, yeah. Thank you very much. I go one slide back. I forgot something. So if you are not aware to work with full metal, thank you very much, Romy, then it's better to inform how to mill cobalt chrome in the Matic and how to mill titanium in the Matic. It's a special way of nesting. It's a special way of preparing the milling machine. So don't do it if you have no experience. Call your local dealer or the help desk or some of our trainers here to be supported when you try this in the first time. So very good, Romy, to remind me on this. Perfect. So non-experienced hard metal users, please ask us first how to do this. There's a special training for this, but if you start without a training, it would not be the result you are expecting maybe. So we go on with the implant features. Implant features is don't use scan body. What does it mean? If you don't have a scan body, the idea behind that is that several users would like to scan the TI base because they have no scan body, or no scan body is available at the moment. They haven't got this in the lab, or they simply want to save costs or want to be faster. And then you scan your TI base directly. TI base scanning, you have to avoid the reflection. That means maybe you sunblast the surface, or you need a scan spray. And the whole of your TI base you have to close with a scan wax, for example, and then it looks more or less like a die with a geometry on the top. And later on in the workflow, you come to the window. So at first, of course, the detection of the margin. Later on, you come to the screw channel definition. And with clicking on this die or on this abutment, I can define the place where the screw channel has to be, and I can define the diameter. And if I click a little bit outside, I also can define an angulation here. And this makes it, of course, very simple to design a crown over an TI base. So stock abutments need different libraries. Stock abutments are libraries which you can download from the Exocad portal, import, and at the beginning you can detect implant positions. So this is not a so much used feature, but sometimes you have this to do. So go to the homepage of the implant manufacturer, or maybe you can find this type of implant on the Exocad portal and download it, import in your library, and then you can directly use and select this prefabricated abutment, the stock abutment, for your construction. Don't use scan body. One more hint: if you are not experienced to do this, so at the end maybe you have to define the fitting here, the cement gap, and the part without any gap, or maybe if you use scan spray, then you have to define the radial value u. So try it out, and then it will work properly good. It starts with the detection of the margin, and later on with a screw channel, more or less like a coping. The stock abutment will be loaded from the library, and you design your crown and bridge directly on top of this. Tree implants is now available, I think, 1.5 year minimum, maybe a little bit longer. Tree implants is an implant type, for those who don't know this, an implant type without an abutment. So our crown has a direct connection to the geometry of the tree implant. This is validated from us, and what we now implemented is the solid FX multilayer and the DRS multilayer blocks. That means we have a workflow for these blocks with different mandrels here. Be careful, this is only possible with 5x milling machines, not with a 4x milling machine. And what you need here is, of course, for the zirconia, the normal zirconia burrs, 2.5, 1.6. And additional to that, the T-shape. The T-shape opens the hole from the implant direction and mills the seating part of the screw head, and the ST 1.2 ST mills the geometry from your crown to the tree implant abutment. If you want to work with 3 implants and you have no experience with that, so visit their homepage, and before you start, there's a validation, like a certification, and they will guide you through this. Then you get an explanation about all the different screw types and whatever, and then you can be sure that you use it in a right and proper way. What we are doing, we implement it in our software. We make it possible to mill with this kind of burrs, and we have now different materials here to use. We also have a look to the D-flow workflow. D-flow before was FDS, full denture system. Now we call it D-flow because it's a little bit wider. We are able to mill the teeth arches, for example. And we have one more feature here. Customers would like to adapt the teeth to a pre-op. That means sometimes the old denture, or sometimes a setup which I did before, so I can implement the setup, or I can implement the shape of my old denture, or the placement of the teeth of my old denture. Copy this via pre-op to the full denture workflow, and then I can make more or less like a duplicate for an existing denture. Okay, the second possibility I just mentioned, it's to create new shapes out of a pre-op scan or other sources. Another fine thing is the monoblock. The monoblock mode, the monoblock only mode, gives you the opportunity to make a try-in before you are manufacturing the dentures. So the try-in can easily be printed, so it's a low cost, and you can set up everything: the bite, the height, the aesthetic, and if everything is fine, then you can go on with your construction. And why it's now a benefit? Because we can do it 2 steps before. So it's not necessary to adapt the teeth against the base to have all the cavities to glue in. We can make it 1 step before. And therefore, if there are changes during the try-in and I want to go back to my CAD, it's not necessary to delete the constructed parts to go on with my constructions. So very, very nice here. 2 steps earlier, and I easily can make a try-in. I love to have this mode. I always using try-ins before I start full dentures in real. One more thing to consider is the 3D denture parameters for printed bases. So we have difference if you want to mill a base or print a base. So at the beginning, you decide, do I want to mill? Then I go to the milling options. This is the erosion base, for example. Or I decide in the material 3D denture. And then in the background, other features are working. And these features are, for example, the block out angulation of the model. If we don't block out, we will have some problems in milling. But if we don't block out, we will have no problem in printing. And that's the main difference. And 2 slides later, I will go to details with this. But this is first information. The block out angle was now increased from -9 to -55. So nearly no undercut will here be blocked out for printed bases. So if you decide to print a base and take this STL file later and want to mill, this will not work. This will not work from the base, and this will not work from the cavities. That means the connection between the teeth and the base. So be careful with this to avoid any disappointment. Come back to the pre-op scan. Pre-op scan is working like this. I have a little video, so you can select the teeth, invert everything, and then the bluish part is deselected, and only the teeth shape will be used for filling the library tooth in this, more or less in this shape. I will show you the video shortly. The setup of the teeth, the positioning here, more or less in the pre-op scan. Then adapt to pre-op scan. I choose here by click. I click and then I invert, and then I can adapt the model teeth to my pre-op scan. And so easily I can use the design of an old denture or of a setup using for my setup in the full denture workflow. Nice to have it. In the future, maybe we will talk about duplicating dentures. So this is the precise part of the D-flow changes with 3D denture material. With compensation means the sharp edges, if I plan to mill sharp edges, the edges always will be round, so that the burr has enough space. This is more or less a tool compensation. And if I plan to print, then I can leave sharp edges, because sharp edges can easily be printed in both parts, the teeth and the base. And consider this: you have influence now in the database in the first window with a block out angle, and it shows you that milling tool compensation. Normally it was hidden, and here it's on 0. So let's go on to the match 2. One part in the match 2 is the matic, the C-clamp, now available. C-clamp is not new. We have the C-clamp since nearly 1 year. First, we implemented it for motion 2 and motion 3. Meanwhile, we also have it for the matic. Of course, we have here some features and benefit. You can easily mill undercuts if you have anterior constructions like here, without any restrictions. So this is more or less a plus. If you see here the outer line of my milling path, and I put it very far, my construction very close to the edge of my blank, then you can see I can save a lot of material here, which is not at the blank. I can be very close to the edge of the blank. But all in all, the higher aesthetic, the higher milling result is for me the reason to use the C-clamp also for the matic. Here is the C-clamp for the motion 2 and 3, and here's the C-clamp for the matic, and available for these materials: zirconia, sintron, temp, and PEEK. To choose the C-clamp, you decide this in the match 2 when you select the blank and the holder in this. Then you go to the holder 3. This is called the C-clamp holder. If you have just a blank in your library, you click on your blank and then on the left side in the match 2, and here you can select also the C-clamp holder. Maybe before using the C-clamp holder, the blank was used in the normal holder. That means in the 98, and then you jump to the C-clamp. So it's also possible to jump in between different holders with different constructions. A really nice option or nice tool is now the diamond finishing. And what I heard from the market is that we are the only one who are offering this. Diamond finishing is a very important thing if you want to mill composite blanks or composite blocks. And here what we are doing in our milling strategy, we are using a combined milling strategy. And that's the new kind of combination. We mill and grind together to have the finest surface as a result. So what does it mean? First, we are using burrs, the diamond coated burrs, and later on we are using our new diamonds, not the old one. These are now called different. I explain you later on. So in combination of both, we can mill approximately 100 units per set. So this is also outstanding. And we are doing it like this. The burrs are milling and roughing the construction out of the blank, and then the diamond is polishing. So 2 diamonds normally are more or less polishing the surface, and that leads to these kind of constructions. You can see it's really completely even. It's looking like polish. You have a little luster here on the surface. On the left side, this is in standard mode, and on the right side, this is on HD mode. HD mode means the smallest diamond is 0.4, and a very nice option. What kind of materials are these? We have validated it for Voco Grandio. Voco Grandio is one of these blank types, highly filled, so we call it composite. In US, it's very often used for Crystal Ultra. Crystal Ultra the name is Ambarino. Ambarino is a German material. And in US, it's called Crystal Ultra. Ambarino, also a multi-layer with a really nice aesthetic. I think Ambarino is also very famous in Italy. So try this new workflow, the diamond polishing, with this high interesting materials, the multi-layers here. Developed for all our milling machines. Together with this, we have a milling strategy for hybrid mill blocks. Maybe you can see this on the left side. The block has a different shape to the right side. And this is because we can turn now blocks. What's the reason behind that? I'll explain you in some seconds. I come back to our milling strategy. The milling strategy is under milling parameters, it's diamond. And with diamond, the milling strategy knows that we have a combination of burrs and diamonds. In standard, this is in standard, we use DMB-DC. DMB means dry milling block, and DC is for diamond coated. So the surface here has a special coat. It's much more harder than the normal rotos, and therefore we can grind this kind of composite, this highly filled composite filled with glass and filled with some parts maybe of zirconia. It depends on the manufacturer. In standard mode, 2.5, 1 millimeter, 1 millimeter BLG. BLG are the new diamonds, block grinder diamonds, which you can use for speed lining milling strategy. Or in HD mode, let's have a look what we do here. We're using the 2.5, the 1 millimeter, the 0.6, and then the shape is quite good, quite nice. And then we use for polishing the 1 millimeter diamond and the 0.4 millimeter diamond, and then you have a final outstanding result. This is really cool. This is so cool. So please try to use it in your milling machine. An overview about the times. So times are in the expecting area, I think. In standard, 24 minutes. In HD and diamond finishing, 26 and 25 minutes. Diamond finishing HD with the smallest burst, 26. So the result is really nice. And this is for crown and inlay and the veneer. Very interesting, the new materials, the new hybrid materials. Hybrid blocks, 30-degree rotation. In some areas of the world, there are manufacturers who offers maybe the universal mandrel with 2 notches. And if you have 2 notches, you can set it in, you can fix it in our machine in 2 different angulations. And we refer to this, I think, mostly used in the Asian area and the Asian market. Also, there can be more than 2 notches here. And what you can do, you can select how your block will be loaded. Is it more this is an upright position or in a flat position? So in the upright position, the construction won't fit here because it's too small. But if I turn it in 90 degrees, then it will fit here. So take care that you order this one if it's possible, and you are not turning it in during the nesting, you are directly selecting it before nesting. So now implement it here, hybrid grind 90%, and then it's more or less upright or it's flat, and your construction will fit in. So you pre-select while loading. It's not rotatable. Solid bion, our wonderful new material, amazing results. A combination between strength and translucency. What we can achieve here is we have over the whole profile here the same strength. It's around about 1100 megapascal, and this allows us for full arch bridges. The second thing is here we have a new layering concept here, and we have a very, very translucent part here for the incisal area. So this looks more or less like FX, but the stability is more or less like Gen X. So the combination is outstanding here. We can use the solid bion in the DRS in 45 minutes, so single units or small bridges like 3-unit bridges can be sintered a little bit longer, but single units in 45 minutes. And we have a frame rounded, this acrylic frame, that this makes it more stable during the milling and during removing maybe out of the machine and bring it back. So the risk of chipping and breaking is decreased. It's implemented now under material, of course, available for all dry milling machines. So we mill it dry in our machines. And here, please take care. Download the new sinter programs from Therm 3 and Therm DRS from AG Live, from AG Live. The new sinter programs we have different speeds here and different holding areas. And at the end, we have a higher temperature from 1500 degrees. So what you can do, Therm 3 and Therm DRS automatically update. If you have a Therm 2 or other furnaces, we can give you a handout with the parameters and you can make a manually programming. You can sinter the bion with all our other zirconias except zirconia ZE. ZE is our normal zirconia, and this normal zirconia, what we have has to be separated in a tray, in a different tray, like always. But the others are quite good in the same tray because they are translucent as well. So this is the only thing I have to give you here with. ESC, what does it mean? Angulated screw channels. And this is in titanium now possible. What does it mean with the update 4.4? So if you have angulated screw channels, and mostly you have it, and you are using TI bases or multi-unit abutments, then we are now able to mill out of titanium. We can it in zirconia since a longer time. I don't know when we started with zirconia, but what we are doing here, we are milling out the seating area of the screw head here, and this of course with a special geometry. The angulated channels work from 0 to 20 degrees all over the model. That means in a 360 radius bar, we can provide a really precise and reproducible workflow here with the accurate fit. So we are also sure if you make a fitting test here, and therefore we need a new burr, and the burr is called Roto Titan 1.5 T-shape, and the T-shape is looking like this. And what is the T-shape doing? The T-shape is milling in the direction of the implant from the bottom side, going through this hole if this hole is open, and then he can mill here this platform for the head of the screw. It's also possible if the head of the screw is not in 90 degrees, some are conical, it's also possible to mill here conical parts until this is the limit, until the angulation will start here. This is the overview about the burrs for titanium. We have 7 meanwhile. So the T-shape is the burr who opens this workflow. Very important, we are going to the limitations. Of course, we need special space to make it possible to reach every area for the burr. And therefore, this hole has to be minimum 1.6 millimeter. 1.6, so the burr is 1.5. He needs a little space to come in. This part here should not be longer than 7.1 millimeter because the burr is not longer at the end. And here, this is the screw channel opening here, must be larger than 2.28. Otherwise, it's not able to mill out. But when these restrictions, you consider this, then it will be very fine. And then you can easily use the TI, the T-shape burr for angulated screw channels in these kind of titanium bars. And by the way, titanium is easy to mill in our Matic. I tested a long time. It's easier to mill than compared to cobalt chrome. Avoid any how does it call this? Sorry, I'm not losing the word here. These artificial things here, take care, because if you have this is more or less a bad scan from the model or bad construction, then of course it will not be probable to mill. One more, the 1.5 T-shape, and these are the other burrs here. So I think I'm just in time. Sorry, a little bit longer, 50 minutes. I suppose it only has to be 45. Thank you very much for joining this session.